Kafka commit log and its role in message persistence. The Kafka commit log is a fundamental component of Kafka's architecture. It is a sequential, immutable log file where messages for a partition are stored. The commit log serves as the central mechanism for achieving message persistence, reliability, and scalability in Kafka. What is a Kafka commit log? A commit log is a persistent storage file that appends records, messages, sequentially as they are produced. Each partition in Kafka has its own commit log stored on the disk of the broker managing that partition. Messages in the commit log are uniquely identified by an offset, which represents their position in the log. Key characteristics of the commit log. 1. Sequential writes. Data is written sequentially to the log, minimizing disk seek times and maximizing write performance. 2. Immutable entries. Once a message is written to the log, it cannot be modified or deleted until retention policies apply. 3. Partition storage. Each Kafka topic is divided into partitions, and each partition has its own separate commit log. 4. Log segmentation. Logs are divided into smaller segments for efficient management. Older segments can be compacted or deleted based on configured retention policies. Role of the commit log in message persistence. 1. Durability. Messages are persisted to disk in the commit log, ensuring that they are not lost even if a broker crashes or restarts. The replication mechanism ensures that a copy of the log exists on other brokers, replicas, for fault tolerance. 2. Message retention. Kafka retains messages in the commit log for a configurable duration or until a specified log size is reached. Consumers can read messages even after they have been processed by other consumers, enabling replayability. 3. Fault tolerance. The commit log is replicated across brokers in the in-sync replicas ISR. If the leader broker fails, one of the follower replicas becomes the new leader, ensuring no data is lost. 4. Efficient reads and writes. Sequential writes and reads enable Kafka to handle high-throughput workloads with minimal latency. Consumers read messages directly from the log using offsets, avoiding complex indexing. 5. Replayability. Consumers can reprocess messages by resetting their offsets to an earlier position in the log. This feature is particularly useful for debugging, analytics, and recovering from consumer failures. 6. Message ordering. Messages within a partition are ordered by their offsets, ensuring strict ordering for consumers reading from the same partition. Example workflow. 1. Producer sends a message to Kafka. The leader broker for the partition appends the